Hello everyone, let us solve the problem can place flowers. Okay, so you have a long flower bed in which some of the plots are planted and some are not. However, flowers cannot be planted in adjacent plots. Okay, so given an integer array flower bed containing zeros and ones, where 0 means empty and 1 means not empty, means if there is a 1, that place is planted, right? And an integer n. Return if n flowers can be planted in the flower bed without violating the no adjacent flowers rule. Okay, so we want to plant one flower. Okay, n equals to 1. This and this positions are planted. So where can we plant our flower? We can plant our flower here, right? The adjacent two positions are empty. We can plant there. We can't plant here and here, right? Because here adjacent left we have a flower, and if we plant here adjacent here we have a flower, right? So this is the position. Similarly, if we see this example, we want to place two flowers. Okay, but it is not possible. We can place one flower here. Okay, but the other one remains, right? If we place here, the rule is getting violated. Similarly here, the rule is getting violated. Okay, so how are we going to solve this? Let's assume this is our flower bed. Okay, if this is the position, this position and this position should not contain any flower. Okay, so that's the basic rule. Okay, so at each step, if we are here, we want to know if the previous position and the next position has flowers or not. If there is any flower in either of the side or both the side, we can't place any flower here. Or if both the places are empty, then we can place a flower here. Okay, this is the simple logic. We will do exactly that thing. Okay, if this problem sounds complicated, I will make it very easy for you. Okay, so let's say we are here. Okay, we want to see if we can place a flower here or not. We can see here already we have a flower, right? So we won't place a flower here. Okay, so let's move to the next position. Let's move here. Okay, can we place a flower here? Yes, there is a chance. This place is empty, right? But before placing, we have to see if the previous position is empty and the next position is empty or not. Okay, so in this case, the previous position is not empty, but the next position is empty, so we can't place a flower here. Okay, so let's move to the next position here. Before placing, this place is empty, we can place, but before placing we will see if the previous position is empty and the next position is empty. Yes, both of them are empty, right? So we will place a flower here. Okay, how many flowers we placed? We placed one flower. Okay, done. Now let's come here. Can we place a flower here? Yes, there is a chance, but the previous as well as the next position is taken, so we can't place a flower here. We will come here. Can we place a flower here? Not at all, because there's already a flower. Okay, let's move to the next position here. Can we place a flower? Yes, we can, but the previous position is taken, right? So we can't. Okay, let's say we have one more position here. Okay, so from here we will come here, right? Can we place a flower here? Yes, there is a chance. Is the previous position empty? Yes, it is empty. Is the next position empty? There is no position, right? There is no chance there would be a flower, so we can definitely plant a flower here, right? Because see, in the first position we have a flower, right? There is no flower here, no chance to put any flower. But that means if these are the extreme indices, okay, if these are the extreme indices, okay, it doesn't depend if one of the side exists or not, right? If this side is empty, we can place, or if we are here at the last position, if the just left position is empty, then we can place, right? So this is just simple edge case. Okay, so this is the thing. At each step, check if the previous position is empty and if the next position is empty. Okay, otherwise, if we are at extreme indices, let's say the first index and the last index, okay, then we will just see if the next position is empty or not. Okay, if we are here, we will check if the next position is empty, or if we are here, we will check if the right position is left position is empty. Okay, so if both left and right are empty, then we can place a flower, right? We can place a flower. So this is the simple idea. So let's code it now. So we need a variable planted, okay, equals to 0. Okay, let's take length len because n is already taken, right? So flower bed dot length. Okay, what are we trying to do? We are trying to fill each possible position. Okay, it doesn't matter how many flowers we have to plant. Okay, if you are able to plant n flowers or more than n flowers, okay, then that would do our work, right? If you are able to plant exactly n flowers, then that's fine. But if we are able to plant more than n flowers, that's much better, isn't it? If you are able to plant more than n flowers, then planting n flowers is nothing, isn't it? It's definitely possible. So we will plant as many numbers of flowers as possible. Okay, so for int I equals to 0, I less than len, and I plus plus. Okay, if flower bed of I is 0, if this is an empty position, then there is a chance, right, to place a flower. Okay, now the thing is, our previous position should be empty, right, and our next position should be empty, isn't it? If both of them are empty, if previous empty and next empty, if both of them gives a true, then we can place a flower in that position, right? Flower bed of I equals to 1, right? We can place a flower there, and we can say that, okay, we have planted one flower, right? At the end we will return the number of flowers that we planted, not number of flowers. If we could plant n or more flowers, isn't it? Okay, now what are these conditions? If if we are at position I, okay, then our previous position is definitely empty. If we are here, then we can definitely plant a flower here, right? Because this position is empty, isn't it? And if we are at the last index, we can place a flower here because this position is empty. We can place flowers at the extreme indices, isn't it? If this side and this side are empty, isn't it? So if I equals to 0, we can place a flower here, previous position is empty, or our uh, flower bed of I minus 1 is 0. Okay, that means, let's say if we are here, okay, flower bed of I minus 1 is this position. If this position is empty, 0, then that means the left previous position is empty. Okay, so either of them would be true, and if the position is empty, previous position is empty, this will be a true, right? Otherwise false. What about the next empty variable? If our I is the last index, okay, if our I is the last index, we are here, so the next position is of course empty, we can place, isn't it? Or flower bed of I plus 1 is equals to 0, isn't it? We are here, if this position is empty, okay, we want to check this position, if this position is empty, so this is the condition. Okay, so if both of them are true, that means both left and right adjacent positions are empty, so we can place a flower in that position. Okay, and we increase planted plus plus, and at the end we return if we planted n flowers or more than n flowers. Okay, so this is the simple solution. Let's run it. Looks good. Great. So this is the simple solution. Okay, the time complexity is a big O of n, isn't it? So yeah, if you have any doubt, you can comment, and if you like this video, do hit the like button, share this video and subscribe to my channel, and I will see you in the next one. Bye bye.